Welcome to the NASA Data Challenge.
My name is Sarah Markov.
I'm Urmila Cherai-Murray.
Hi, I'm Eileen Meyer.
So you're looking at the first ever groundbreaking image of the light just outside of the event horizon of a supermassive black hole in the M87 galaxy.
A galaxy is a collection of billions to sometimes trillions of stars that all live together in the universe. At the center of almost every galaxy we've looked at, we found a supermassive black hole. The image of M87 taken with the Event Horizon Telescope is the first time that we've been able to directly look at a black hole.
So what you're looking at is actually an image of the shadow of the black hole in M87. This is light coming from hot gas really close to the supermassive black hole.
That image of the ring around the black hole is very iconic and something that makes M87 really popular among astronomers.
So for the sky watchers out there, M87 is in the constellation of Virgo, as the second largest constellation in the sky.
And it sits in what we call the Virgo cluster of galaxies, 55 million light years away. M87 and our own Milky Way are extremely different galaxies. M87 is what we call an elliptical galaxy. For obvious reason, it looks like a big elliptical ball.
The Milky Way is a spiral galaxy. It's only about 100,000 light years across, I say only, whereas the elliptical galaxy of M87 is probably at least 200,000 light years across. So it's significantly bigger, and it contains more stars compared to the disk of the Milky Way.
M87 has one of the most dramatic examples of what we call a jet. This is coming from the region immediately surrounding the supermassive black hole.
First, you'll notice that it appears to come out of the center of the galaxy, and it does in fact come from very close to the black hole, but it's not actually coming out of the black hole. The matter that's falling in never makes it all the way in and is in fact shot back out into these jets.
The jet moves at 99% the speed of light, so it's one of the fastest moving things in the universe. The jet of M87 is coming almost directly at us. It's only offset from our line of sight by 20 degrees.
We know that supermassive black holes like M87 produce bipolar jets, two jets pointed in opposite directions, but we can only see the one that's pointed towards us.
And because it's moving at almost the speed of light, that means it's brighter when it's pointing towards us than away from us.
We can't see the light that's moving away from us because it gets much dimmer as it moves away from us.
So in the visible light and infrared light imaging, you can see the general glow from the starlight as well as the jet. The jet also has what we call counterjet pointed in the opposite direction, which we can't see in the image, but we can see the effects of it. We can see that it has started heating some gas on the other side, and that is actually best seen in the infrared image.
The stars in elliptical galaxies like M87 are most densely concentrated at the center and then get less and less dense as you go outwards.
So in the radio image of M87, we notice some interesting differences from the visible light. First, the starlight is gone. You cannot see the stars in the radio imaging.
But here what we're seeing is a larger view of the entire system, and you can see here very well that the jet is really a continuous stream of hot magnetized gas. And then within that, there are quite a few structures, and in some cases, you can look closely, there's almost a helical pattern moving along the jets. And then this fluffy stuff that's surrounding it is the sign of the jet's interaction with the larger galaxy around it.
The X-ray image of M87 is particularly visually stunning. On the one hand, you have a lot of gas flowing in towards the center of the galaxy from its surroundings, and this gas fuels the activity in the immediate surrounding of the black hole and launches powerful jets which then travel outwards. So you see this dance of gas moving inwards and then fueling these jets which move outwards.
And on the other side, what you can see is there's these kind of bubble-like structures in the hot X-ray gas. And what that means is that the jets, both today and in the past, have really inflated little balloons inside the hot gas.
Have you ever wanted to make your own astronomy image?
We'd like to hear about your ideas.
Okay, we want to see your image. And please share your images with us and tell us about the choices you made.
Did you pick particular colors because you liked them? Was there some scientific reasoning behind it?
We'd like to see what you've done.